You should have standard N1 notes out in front of you, either your own note packet or the one given to you if you didn't bring your note packet. Sorry, I'm just getting organized here. Alright, so this standard has to do with data and patterns and how to interpret some of that data and patterns. Whatever profession you decide to go into, or within any newspaper or magazine you read, you will come across data. You come across data every day. Data is analyzed, interpreted, modeled, shown in graphs, explained in words, and many times manipulated so that the reader sees one picture, but maybe not the right picture. Our job as consumers in this country is to see that data and be able to interpret it for ourselves. So this unit and this standard, you'll be doing just that. You'll be taking data, analyzing it, graphing it, and explaining it so that bias and manipulation is greatly reduced. Bias is basically tweaking the data to make it say what you want it to say, not what it really does say. You need to start with one of the most common graphical interpretations of data, the normal distribution curve, and I guarantee each of you have seen a representation of this. It helps us interpret probability, the likelihood of an event happening or not. We're going to have a few short definitions at first. A normal curve is, well, we'll start with saying that it's symmetric about the mean, and we'll discuss what mean means here. It's a bell-shaped curve. Area under the curve represents the distribution of your data set, whatever that looks like. The mean is the average of the set of data that you're given. And then standard deviation is the name given to a numerical measure. So it's a measure of the dispersion of the data from the mean. The more spread out the data, the higher the standard deviation. Okay. So there's some properties that we have to be aware of, and we'll list out the properties first, and then we'll actually draw some normal distribution on the next page there. Oh, sorry. I think I might have been zoomed in a little too much. There. Okay. Focus one more time. So the first property is, and I should give you the symbols for standard deviation. Mean is going to be an X with a line over it. So if you see that in math, that represents that means whatever that is equal to is the mean or the average of the set of data. Standard deviation is going to be this symbol. It's like an O with a little line coming off of it. So that's the variable to indicate mean or standard deviation. Properties. The total area under the curve is 1. I should say under the normal curve. Because in other classes, you might dig into probability and statistics a little bit more, and there are other types of curves, not just normal curves. So, all right, number 2. About 68% of the data lies within one standard deviation. About 95% of the data lies within 2 standard deviations. And about 99.7% of the data lies within 3 standard deviations. Okay, so to show you what this looks like graphically, and I should say again that the normal curve is a very typical way that data is presented. So you'll see a bell curve on the next page. You'll recognize what it looks like because I know you've seen it before. And it's just a way to organize data so answers or probabilities or values are easy to find. So you don't have just a list of numbers to work from every time, but you can organize it in a way that is nicer to look at and easier to use. Okay, here we go. Normal curve. I want you to draw, in both cases, a line straight down from the top of your bell curve and label that as your mean. And that's actually what you're going to start with every time you have a mean value or you have to draw your normal curve. You're going to start with your mean. So about right here, draw your next dashed line down, and this is going to be your mean minus 1 standard deviation and your mean plus 1 standard deviation. So remember, the standard deviation is how spread apart your data is. It's a measure of that. So you're going to add and subtract to find that chunk of area. That represents where 68% of your data lies. Okay, so the bulk of your data is going to be right in that center part. Draw another dashed line down. That's going to be your mean minus 2 standard deviations and your mean plus 2 standard deviations. And from there to there, so within 2 standard deviations, that's going to be 95% of your data. And then last little bit here, that's going to be your mean minus 3 standard deviations and your mean plus 3 standard deviations. That's going to be 99.7% of your data. If you're looking for trends, organizing your data this way is very good because, as you'll notice, there's not as much data that would fit under the curve here. This would be where your outliers are. So if you have a whole set of data, you're going to have some numbers that don't seem to fit, like some that are really big or some that are really small. They're going to be the ones represented out here. They're not going to be where the bulk of your data is, probably the meat of your data that you're going to pull the most information from. Okay, so I want you to have the same markers over here. Okay, so 1 standard deviation, 2, 3 standard deviations. And then we're just going to mark each chunk. So if I know that that whole middle section is 68%, if I split it down the middle, that means one part of this is going to represent 34% of my data. And it might seem silly while we're labeling all these percentages right now, but it's pretty essential to when we start to find probability that we know how much of our data set lies within that. So 34%, this is 13.5%. That's going to be 2.35%. And right here, 0.15%. So it tells you how much of your data actually is in each one of those divisions. Might be good for us to do this right now. I'm going to rewrite these as decimals because when we calculate using these percentages, we actually calculate using the decimals because we have to convert it to decimals in order to multiply by anything. So, okay. So finding a normal probability. You have a normal distribution curve. It has a mean and a standard deviation. And I'm just going to label the standard deviation as SD. Okay, so I'm just giving you symbols. For a random x, so again, the curve organizes the information, and we're saying for just some random number that you just pick out of your data set, so for a random x, find the probability that it lies within two standard deviations, and we'll say two standard deviations less than the mean. This is just getting us comfortable with some of the terminology, this example, so stick with me. Alright, so we're talking about a normal distribution curve, so that means I'm going to be able to use this bell curve and these percentages of how that information is organized. It tells me I have a mean and a standard deviation. It doesn't tell me what those numbers are, but that's okay. If you have a data set and you just pick a random number, we're supposed to find the probability that it lies within two standard deviations less than the mean. So, if you look at your mean, two standard deviations less means it's this part of the area and this part of the area, because from here to here, that's two standard deviations less than the mean. To find the probability, these are the percentages that give you that probability, so you would take the probability in this section, which will be the same as this one, so 0.34, and add the percentage of area I have in this section, which is the same as this one, so 0.135, and 0.34 plus 0.135 gives me 0.475. So, in this case, there's a 47.5% chance that if you have a set of data and you pick just a random number, that it's going to lie within two standard deviations to the left of the mean. Okay, so that's not using data or giving you numbers. Example 2, we're going to actually interpret some data and make our own bell curve here. The blood cholesterol readings for a group of women are normally distributed with a mean of 172 and a standard deviation of 14. So, it gives me some setup here. And before I answer my questions, I'm going to have to draw my bell curve. Okay? So, my mean, they tell me, is 172. And they tell me my standard deviation is 14. Which means if I'm following the same pattern as I have up here, then I'm going to add and subtract to find the values at each one of those markers. So 172 plus 14 gives me 186. 172 minus 14 gives me 158. Do it two more times here. 186 plus 14 gives me 200. Plus 14 gives me 214. 158 minus 14 gives me 144. And minus 14 again gives me 130. Okay, so this is the spread of the data. That means on the upper end of the numbers that they've taken for a group of women, you're having cholesterol readings of about 214. And on the lower end, you're having cholesterol readings of about 130. But since that's pretty uncommon, that's why those are the outliers. The chunk of the data means the majority of your women are getting readings of between 158 and 186. That's going to be the biggest chunk. Okay? So when we start reading or answering some of these questions, about what percent of the women have readings between 158 and 186? So 158 and 186. That's the area or the percentage lying between one standard deviation on either side. So if you look back at your percentages up here, there's 34% of your data in this section, 34% in this section. So if you add them up, you get a total of 68%. So 68%, let's say, lie within one standard deviation. Okay. Readings less than 158 are considered desirable. So that would be our goal. About what percent of the readings are desirable? So you look at where 158 is, and then anything less than that is what we would like. So we're going to take the percentages located within each one of those sections and add them up to get the amount or the percentage that are considered desirable. So in this section here, that would be the same thing as this section. That's 13.5% of the data, so I'm going to take 0.135. Maybe we write it there, 0.135. Then you add the next section, which up here was 0.0235. And then, so 0.135, 0.0235, and then you have 0.0015. So we add that up. And when you add up those three readings, you end up getting 16%. Because you get 0.16. So in all the readings, 16% are considered desirable. Now that's pretty, that's not great. So if you're the doctor that has this group of women and you've figured out this data set, then you're looking at your patients and you're like, wow, 16% of my patients have good cholesterol readings and the rest of them don't. So you know that that's something that maybe you would want to focus on. Teachers use this all the time, like after you do your testing for the state. We get stuff back where it's broken up into percentages, like how far you are off from the average in the state or the country on the ACT, how far above or below our group of students is or class of students is or whatever. It's all based on these types of data organizations. And so that we can answer a question like this, if we know the goal is, let's say, a score of 20 on the ACT, then we can organize our data so that we can see actually how many of our kids or what's the percentage of our kids that actually met that goal or exceeded that goal. You would organize the information in this way, and then it'd be easy to find the probability without looking, because notice here, I never gave you the whole list of numbers. We were just told how it was organized, and then we could figure out any types of these questions. Okay. Standard, let me check my... Okay. I think we're going to call it good for now, because I don't want to really put any more on you. Standard normal distribution, just so that we're looking ahead a little bit, is dealing with a specific type of normal curve. These are 4-type problems, but they're not hard. And I have to give you a chart in order to really talk about it. I was going to fill this out, but I think we'll wait for that until tomorrow and just do it all at once. So that gives you at least your first part for standard N1. Make sure that tomorrow you bring this note packet that you've been working on so that we can finish it out and answer questions if you have them. Okay, see you guys tomorrow.